gained over the last few years. And with a prayer to God and yesterday being Guru Purnima, I would like to recollect all the guidance that I received from all my elders and my superiors. With that, we will start this program. So you must have attended the last session where I had talked about the survey. After visiting the field, the most important step after survey will be the design. So today we are going to talk about design, and design for anyone, even a small farmer can do the design. So we are all aware of how the typical layout of a drip irrigation system is. Typical, we are just going to see how we are going to do the drip irrigation design. So we all know that a drip irrigation design has got three main components. That is the starting with the head control unit, followed by the water carrying system and the water distribution system. So all of us know about this. This is there in my first presentation. So basically we are going to design. So what are we going to design? So let us look at it in the next slide. So before we do, let us understand the objective. The main objectives in designing is we want to have an economical design for the farmer without any compromise. And it should be easy by the farmer to do it, even the field staff or the dealer with very minimum calculation. Those who don't even have a technical background can do this design, and it should be efficient. Not that we are making a compromise. It should be an efficient design, and it should, as per the acceptable norms of the government of India, it should be within a variation of 10% only. And also we should apply the water as required by the crop water requirement to the plant, depending on the different growing stage, different stages. So what are the methods of design that are available today? So let us look at the broadly, there are four methods. The first method is called the spot design method. I have just given it a name. It's basically the simple rule of the thumb. It is very easy to learn. It is suitable for small areas. It can be used for flat terrain and even areas having a mild slope, say 2%. What is the meaning of 2%? 2 meter, either a rise or a fall in height, 2 meters in 100 meters or 2 feet in 100 feet. The next commonly used method, which is very widely used by most of us, is the specific discharge rate method, wherein we have to use graphs and Excel calculators. These are very accurate and can be used for any kind of area. They all have formulas within them. They have the built-in formulas. Typically, the modified Hazen-Williams formula or the continuity equation is used. In addition to this, today being the digital age, we have IRRICAD and other softwares, which also is a total design software, which are very accurate. The only thing challenge being that it has got a steep learning curve, means you will take some time to learn it. It can be suitable for any areas, from a medium area to a large area. It can handle any kind of terrain. So if you have got the data from the GPS, it can directly come into the software. And finally, when we are doing very large projects like lift irrigation and combined with micro irrigation, then we have softwares like EPANET, KY pipe and FEM softwares, which are very dedicated, and they do very specific work like checking the hydraulics of the entire system, like whether there is water hammer surge pressure that is going to occur. And if you are going to have a SCADA control systems, even that also can be verified. Now, today in this webinar, I am going to confine my discussion only to the spot design method, which is very simple and easy for the farmer to adopt. So what are we going to do? What are the components that we need to design or select? So we are going to look at one example each of an online irrigation system and an inline irrigation system. So the first step will be to select the system, whether it has to be an online or an inline, wherein we'll be looking at how to select the diameter and what should be the pressure rating. The second step will actually involve the design or the selection of the sub-main line, which is also called as a manifold. The third step will be the selection of the main line. And the fourth step will be selection of the right kind of filter depending on the water source and what is the kind of fertigation unit that has to be. And also check what is the head loss calculation, which is quite complicated. I have made it very simple. I will teach you a simple method wherein you can do the calculation quickly. And finally, we will check whether the existing pump in your plot is suitable in terms of head, discharge, and horsepower. So here, basically, the water from the drip system starts from the water source, gets into the main line, then gets into the distribution system, then flows into the emitters, and that is how the design is happening. Water is flowing. But when we do the design, we will follow the reverse methodology. That means we'll start designing from the back, from the emitter into the lateral into the submain into the main, and main into the filter. So the design process essentially, we will start from the bottom up approach, not from the top down approach. So first thing is, how do we select which is the kind of system that I have to adopt? So here very clear guidelines have been given by the government of India that whenever you have a close space crop, what do you mean by close space crop? The row to row spacing between the crop, if it is 1.8 meters and below. So that is the basic condition. So like we know crops like vegetable, sugarcane, vegetable is 1.2 meters, sugarcane is varying from 1.2 to 1.5, flowers, turmeric, onion, you name the crop today, even potato, paddy, even wheat, all these close space crops basically will have an inline drip irrigation system. The inline drip irrigation system is what you have that drip line and you see the water. So this is something like this. You have the drip line and the dripper is already fitted along with the pipeline. So basically it's an inbuilt system. And next will be the wide space crops. As you can see here, what will happen? There is a distance between the two plants. That means if I put an inline system over there, I'll be wasting water in between. Therefore, I go for an online system. That means I will punch. That means I will take the lateral, I will take the dripper and punch it. So that means I'm going to fix it on the line. So that is why it is called an online drip irrigation system. Any wide scale space crop more than 1.8 meters, typically like mango, apple, coconut, pomegranate, sapota, arecanut, you name any horticulture or fruit crop, everything can be covered. Today, the trend you can see on the right side, the dragon fruit has become very popular. So basically, you have inline drip irrigation system and an online drip irrigation system, and we are going to see how to do the design for this. So before we do the design, there are certain things that we need to know. For example, you have a pipe, you have a 12 millimeter lateral, how much water can flow through it? So you need to have an approximate idea. So whatever I've given you over here is an approximate thumb rule method, wherein if you have a 12 millimeter lateral, the maximum water that it can carry will vary from 200 to 250 liters per hour. Similarly, if I take the next size 16 millimeter, it can carry between 350 to 370 liters per hour. Similarly, for 20 millimeter. Now we also have the first one, what I told you was the plain lateral, which means there is no dripper, it's only the lateral. And if you have the inline tubing, then you can go up to 450 to 500 liters per hour. And also for inline tubing of 12 millimeter, you can go to 280 to 300 liters per hour. What is the velocity considered in this assumption is we are assuming that the flow, the velocity is the speed of the water in the pipe is not going to exceed 1.5 meters per second. So it could vary from 1.2 to 1.5. And like I told you in the beginning, we are not making any compromise in the design. The maximum discharge variation permitted between the highest point and the lowest point should not be more than 10%. We can also do the design. If you want even a more accurate one, you can even make it to 5%, 7.5%, 10%. There are charts, and from the charts readily you can look up the length. And this is coming to the, once we have seen the lateral, now we are coming into the basic, that is the water conveying system, where you have the PVC pipe. So PVC pipe, you need to know how much is the water that has to flow. So there basically you have starting from 40 millimeters right up to 110 millimeters. 40 millimeter can carry anything between 3,600 to 4,000 liters per hour. And if it is a 63 millimeter, it can carry between 11,800 to 14,000 liters per hour. So for our discussion today and for my design, I'll be looking at these three sizes, say 40 to 63. I have given you the flow rates for the other sizes. Again, we are looking at the velocity consideration is 1.5 meters per second is the maximum permissible velocity for a PVC pipe, and it can go up to 1.7 meters per second for a high density polyethylene pipe because they have a greater strength. And the head loss that we are permitting in our design is not more than 2%. That means what is the meaning of 2% head loss? For every 100 meters flow of the pipe and water flows to the pipe, the water rubs against the wall of the pipe and that creates friction. So that will be restricted to 2 or 2.5%, so that you don't have surge pressure or water hammer pressure or any kind of leakages. So this is basically the design constraint. So before we start the design, let us look at the various wetting patterns in the different types of the soil. So the wetting patterns in the different types of the soil is a very important parameter that we have to consider when we want to select the emitter. Now, if you can look at the first one, it's a sandy soil. And you know that in the sandy soil, the water has a tendency to go right down. That is, the vertical movement of water is greater than the horizontal spread. Whereas in case of a medium soil like a red soil, you will have almost an equal distribution of horizontal as well, vertical as well as horizontal movement. And in case of a clay soil, you will have the vertical distribution anywhere from 3 to 3.5 feet. So here, basically, depending upon the type of the soil, we will go in for the emitter spacing. So for a sandy soil, we generally keep the emitters closer. So we will have 30 to 40 centimeters. And if it is a loamy soil, the distance between the emitters can range from 40 to 50 centimeters. And if it is more than that, like a clay soil or a black cotton soil, the spacing of the emitter can be 50 to 60 centimeters. So now let us look at the first example. The first example is the online drip irrigation system. So as I told you, we are looking at a plot. I have taken a theoretical plot of around 2 hectares. The shape could vary. For the sake of understanding a design, I have taken a rectangular plot. And we are having the borewell situated at about 25 meters from the plot, one corner of the plot. And the plot has mango, the crop is mango, which has got a spacing between the row of 5 meters and spacing between the plant also 5 meters. And when we, I would request those not talking to kindly mute their microphone.
वाईफाई करके
And therefore,
ऊपर वाले को टच करो, जो दिखाया है उसको टच करने के बाद
Please continue, sir. Sir, continue, sir. Hello. Sir, unmute your mic, sir. Sir.
are you able to hear me now?
Yeah, okay. Now I am able to hear.
Somebody is, yeah. So here basically, when you are looking at the plot is 100 meters by 200 meters, and the area will come to 100 multiplied by 200 is 20,000 square meters or 2 hectares. The water source is a bore well, and the bore well sometimes also called as a tube well, and the water flow in the bore well is around 7,200 liters per hour, 2 LPS. This I will tell you in the end how to calculate this. And the elevation difference in the plot, that is from the bore well to the last point, is around 3 meters. That means you have to take the water from the ground level to a point almost 3 meters away. And this plot is fitted with a 5 HP 8-stage submersible pump, and the motor sitting depth means where is the motor sitting from the ground level to the bottom is around 40 meters. So this is the data you have gathered after your survey. So let us understand how to do the steps step by step. So the first step that we need to do is to select the system. So as we understand, this is a 5 meter by 5 meter means what? It is a wide space crop. That means it's going to be an online drip irrigation system. Then we need to give the required amount of emitters or drippers that is required for the system to operate. So we will provide 8 liters per hour, 4 emitters per plant. So this is the second step. After that, we will have to create the block or the input output matching. This is the most important and critical step in the design. That means what? I have a certain quantity of water coming out from my tube well, and I have a certain requirement of water in the field. So I have to match it. So I have to check whether I have enough water in my bore well. So how to do that? So we know the number of plants can be calculated by the formula area divided by spacing. So this area is 20,000 square meters and the spacing is 5 into 5. So you are going to get 800 plants. And 800 plant, every plant is going to be provided with 4 emitters of 8 liters per hour. So the total discharge will work out to 25,600 liters per hour. But what is the water available in the well? The water available in the well is only 2 liters per second, or 2 multiplied by 60 into 60, that is 3,600, 2 into 3,600, which works out to 7,200 liters per hour. So that means what it is it trying to tell you? The water is insufficient to irrigate the whole area of 2 hectares in one single go. That means we have to create zones or blocks. How many zones do we have to create? It's very simple. We know that we have to provide 25,600 liters per hour, and we have 7,200. So 25,600 divided by 7,200, we will get 3.55. Normally, we will not make a zone as a decimal, so it will be 4 blocks. So this is how the design is going to come. At this stage in the design, I don't know any of the sizes of the lateral or the submain or anything. I just know that I have to create 4 blocks. So what I did for hydraulic uniformity, I have created equal blocks. So what I have done to the plot is, this is 100 by 200 meter plots. I have made it into 4 blocks. You can see block 1, block 2, block 3, and block 4. So I made 4 equal parts, and I am going to do the design. So basically, I started with the emitter. So I finished the emitter. Emitter was 8 liters. You are going to give 4 emitters per plant. Now let us get into the next step. In the next step, I need to decide what should be the size of my lateral. So whether I have to go for a 16 mm or whether I have to go for a 12 millimeter. So that is the decision I need to take. And therefore, I will have to calculate the flow in the lateral. To calculate the flow in the lateral, I need to know what is the length of the tubing from one end to another end. We know it is going to be 200 meters from one end to another end. And 200 meters, how many plants will come? 200 divided by 5 will give me 40 plants per row. So that means there is going to be 40 plants, and each plant is being provided with 8 emitters of 4 liters per hour. That is 32. That becomes 1,280 liters per hour. So when it is 1,280 liters per hour, and we are going to break it up. So basically we have the pipeline, we have broken it up into 4 parts. So therefore there is 1, 2, 3 and 4. So what is the discharge in one side of the lateral? It is going to be 1280 divided by 4. That is around 320 liters per hour. So for 320 liters per hour, as I showed you in the chart in the beginning, whether I should go for a 12 millimeter or 16 millimeter, we know that the 12 millimeter, the maximum water that can flow through a 12 millimeter is only 250 liters per hour, but we require to carry a water of 320 liters per hour. Therefore, we will select the 16 millimeter lateral. So that is as simple as that. So we started with the emitter. Now we have selected that the lateral line is going to be of 16 millimeters. After we do, now the water has come in from the emitter into the lateral, and lateral now it is getting into the submain. So submain we'll have to design. So to design the submain, I need to know what is the flow in one block. What is the flow in one block? We know that this is an 800 plant is there in this entire thing. We have made 4 blocks. Therefore, each block will have 200 plants. So 200 plants multiplied by 32 liters per hour, which gives 6,400 liters per hour. And the borewell available discharge, when you switch it on, definitely it is going to discharge 7,200 liters per hour. So that is how it is going to be. So therefore, when we look at the discharge of 7,200 liters per hour, then we need to go for either a 50 mm or a 63 millimeter, because the cost difference between a 50 and a 63 mm is not very much. So you can go for a 63 millimeter or you can go for a 50 millimeter. More important over here, in order to make the design economical, we can go for what is called as a telescope or an economical design. A part of the pipeline can have the bigger diameter and the later part can have a smaller diameter. How is that possible? Because you know the water, when it is traveling from the beginning, as it keeps going towards the end, the water is getting reduced. So therefore we don't need to give the same diameter from the beginning till the end. So therefore we can telescope it. So therefore we can go for telescopic ratio of say 40% of 63 millimeter and say 60% of 40 millimeter to make the design economical and also the quotation economical. Once we have finished the design of the submain line, then what is the next part? Then we are coming back to the main line. So main line, basically the water available in the borewell is 7,200 liters. It's simply a selection. We have already selected 63 millimeters. So it will be a 63 millimeter 4 kg PVC or HDP line. And once we have finished the selection of the filter also, then what is the last part which is coming? That is the filtration unit. So this is a bore well, and this is a system which is going to have an online drip irrigation system. So generally we recommend you to go for a mesh filter or a screen filter, which is most suitable and most economical. And in order to apply the fertilizer, we can go for a 1-inch venturi, so that you can have the acid treatment done, and also we can apply the water soluble fertilizers. So this covered actually the design part. Now we will have to look at the head loss calculation. So basically, I told you in the beginning that the pump is a 5 HP 8 stage. So how much pressure is required to run the system? So the operating head of the online drip irrigation system was 10 meters. That is, you know, the dripper, if it has to work at the inlet of the dripper, it requires a pressure of 1 kg or 10 meters. And when the water flows through the lateral and also through the submain, you are going to have a 10% loss. So that is actually 10% of 10 meters. That is 1 meter on the submain and 1 meter on the lateral. So totally put together, it is 2 meters. Now we know we have to lift water from the borewell 40 meters down, so that 40 meters also will get added up. In addition to this, whenever water flows through any obstruction, there is going to be a loss. So when it passes through the filter, you are going to have a loss of 2 meters. And similarly, when you operate the venturi, there will be a pressure drop. As I told you last time in the fertigation webinar, that when you throttle it, there is going to be a pressure drop between the inlet and outlet. So that will be around 5 meters. And fittings which you have bend, T and other connections will also take another 2. And to calculate the mainline loss, we need to take 2.5% of 225 meters. So how did I get 225 meters? It's very simple. All you need to do here is 25 meters from here, 50 meters over here, and you have another 50 meter here and 100 meter here. So 100, 150, 200 and 225. So that is how we got 225 meters. So just apply the standard rule of 2.5% of 225. That means you take 2.5 divided by 100 multiply by 225 will give you 5.62 meters. Also, don't forget to take the elevation, because you need to carry the water to the highest point. So elevation will be around 3 meters. So totally, when I total up all the head that is required, that will come to around 70 meters. So basically, we have a total dynamic head, as we call it. We need, the pump should give a dynamic head of around 70 meters. So How now we'll have to check the suitability of the pump. Is the pump suitable or not? So we have found that we need to have a head of 70 meters. I told you in the beginning that the farmer is having a 5 HP 8-stage pump. So what is the meaning of a 8-stage? Stage basically refers to the impeller. So as you can see from the diagram, these are the impellers. So this is an 8-stage or an 8-stage impeller. And we know that one impeller, typically if it's the on the current models are even higher, but generally it is around 9 meters. One stage can lift water to about 9 meters. Since there are 8 stages, it will multiply 8 into 9, so you will get 72 meters. So the head available from the given pump is 72 meters, and the head that is required for the running the system is 70 meters. That means the head available is greater than the head required, so the existing pump is suitable. So from the head point of view, the selection is fine. Now, is it okay from the horsepower point? Horsepower point also it can be checked. You have a simple formula. Horsepower is given by the formula Q multiplied by H divided by 75, which is a constant, into 0.6, where 0.6 is the efficiency of the pump. So we know that the discharge over here is 7,200 liters per hour. And in this formula, the consistency of units is very critical. Q has to be taken in liters per second. So that becomes 7,200 divided by 3,600, which is 2 liters per second. And commonly the efficiencies of the pump vary from 0.5 to 0.6. Centrifugal pumps I have taken for the calculation 0.6. So when we put it in the formula, you will find that the theoretical HP required is around 3.11. And I told you in the beginning, this was a pump which is actually having a 5 horsepower. So the existing pump is suitable. So that for the online drip irrigation system, it is completed. So we are able to also check. So very quickly the design has been done. So now I will take you through the second example, which is an inline drip irrigation system. So inline drip irrigation system is used for closed space crop. I have taken an example of just a 1 hectare plot, a 100 meter by 100 meter plot, and the spacing between the rows is 1.2, and the spacing between the emitters is or the plants is 0.6. And the row direction is very important when we do the design, because we need to provide the lateral only in the east-west direction and not in the north-south direction. The water available in the borewell is 10,800 liters per hour or 3 liters per second. This has got a 5 horsepower, 8-stage submersible pump with a motor sitting depth of 40 meters. So how do we do the design? Very typical steps are involved. So first is you want to go for what type of system? This is an inline drip irrigation system. So inline drip irrigation system means, as you are seeing in the photograph also, the dripper is inside the tube. So basically for inline drip irrigation system, this is vegetable spacing of 1.2 to 0.6. So there is no confusion in that. So next we like to go for the emitter selection. Means what should be the discharge of the emitter and what should be the spacing between the emitters. So now this is got a clay kind of loamish clay soil. So I have selected a 2 liter per hour and a 40 centimeter spacing between the emitters. So that is what is the emitter selection. The third step between the online and inline, this is where the difference will come. You have to create the block. So basically we have to know how many zones we have to create. So in order to create the zone, here we will be trying to find out the quantity of emitters and not the number of drippers. So basically we will be doing the calculation. So you know that the area of this plot is 10,000 square meters and the lateral to lateral spacing is 1.2 meters. So if you divide it, then automatically you are going to get the quantity of inline tubing, that is around 8,333 meters. Now every 40 centimeters you are going to have a dripper. So how many emitters will come? So 8,333 divided by 0.4. So then because 40 centimeters converted to meter is 0.4, you will get 20,834 emitters. Every emitter has got a discharge of 2 liters per hour, which means the total discharge required for this plot will be 41,668. So again, like the online design, so you need to calculate how many blocks I have to create. So basically, I know the water available in the borewell is 3 liters per second over here, which is 10,800 liters per hour. And the total discharge that is required for the entire irrigation is 41,668. So 41,668 divided by 10,800 will give me 3.85, say 4 blocks. So the design has become so simple. So here again, I have made the design like this. So I have created the 4 blocks. I have taken the lateral of 50 meters to one side. For uniformity and hydraulic balance, I have taken a standard system of having. I have just shown you an option that you can have lateral only on one side of the submain. So these dotted lines are the submains. These small dotted lines are the laterals, and these are the valves. So this is entirely the system. And what could be the maximum extendable length of the inline? I will show it to you in the chart in the end. So for this particular plot, anyway, I have to create 4 blocks because that is the water available. What it is trying to tell you, I am having only enough water to irrigate only 1/4 of the area. So that is what is the meaning of block creation. So here I have created 4 blocks with 4 control valves. Once we have completed the block creation, then the design is exactly similar to what we did in online. So we know that the discharge, what is the total discharge? 41,668, and we have made it into 4 blocks. So 41,668 divided by 4 will give me 10,400 liters. So basically the borewell is discharging 10,800 and my requirement is 10,416. So my design is correct. So therefore I can start, from the selection of the pipeline, I can start for 63 millimeter up to 14,000 liters we can carry. So we can go for a 63 mm or 60% telescope and a 40 mm telescope for an economical design. So this is how the design for the submain has been done. And finally, when we look at the mainline design, you have 2 options. You have to ask the farmer whether he wants to go for a expansion. Whether he wants to go for expansion, then you can go for a 1 size higher of the pipeline. You can go for a 75 millimeter rather than a 63 millimeter. But if he says there is no expansion, then you can stick to 63 millimeters. There is no problem. And finally, we come to the filter. So in the filter again here, since it's an inline drip irrigation system, and here what will happen is, since inline drip irrigation system is there, and we are going for the disc filter, which is a much more superior filter where you have a disc sitting one on top of the other. It has got a 3-dimensional filtration, which I have explained to you in my first webinar. So we are generally, and if the borewell is containing a lot of silt or stones, then we will go for a combination of a disc filter with a hydrocyclone filter. This also I have explained to you in my first webinar. You can watch it in YouTube. So that is the thing. And after that, we will go for the head loss calculation. So head loss calculation typically remains the same. You will find I have not changed anything. 10 meters is the pressure required for the inline drip irrigation system. Submain or lateral will require 10% loss. Motor will be sitting at a depth of 40 meters. The disc filter is having 2 to 3 meters head loss. Venturi will have a pressure drop of 5 meters. Head loss in the fittings is 2 meters standard for a small plot. And mainline loss, I have to take 2.5% of 125 meters. So how did I get 125 meters? It's very simple. I started from here. What is the length of the longest mainline? From here it is 25. From here it is 50, another 50. So 50 plus 50 is 100. 100 plus 25 is 125. So basically the length of the mainline is going to be 125. 2.5% of 125 is what? 2.5 divided by 100 into 125 will give you 3.2 meters. So basically we also have elevation. So if I sum total the entire operating dynamic head that is required, it comes to 67.2. So therefore, when I check again for the suitability of the pump, I have got a 5 HP 8 stage and the maximum head that is available is 72 meters, but we require only 67.2 meters. From the consideration of head, it is quite suitable. You can ask me a question over here, sir, what happens if my pump has got only 6 stages? Then what I need to do? 6 into 9, 54 meters. That means it is going to fall short. Then you can recommend to the farmer, you can change the pump, but generally he will not do that. You can only go for the changes, increase in the stages. When you increase the stages, the discharge is definitely going to come down. It is not a costly affair. Within about 5,000 rupees, the number of stages can be easily increased.
Excuse me, sir. Sorry to interrupt you.
Yeah.
Some red lines are coming on the screen, sir.
I don't know who is putting it. Somebody else. I don't know.
No. It is not possible for anyone else to put.
I don't know from where it has come.
Okay, fine, sir. You continue.
Now the color is also
I thought if you can rectify, that will be good. That's okay, sir. Okay.
Yeah.
Okay.
I think you have to unshare and reopen the PPT and again share it. That should solve it.
Okay.
Screen sharing.
Screen sharing. Okay.
Stop sharing the screen, sir.
Okay. So where do I stop sharing?
Top, you will get a red color button.
Yeah, stop share. Okay. And maybe I'll share it once more. Yeah, I think now, yeah. Thank you for the suggestion, Jayan.
Yeah. Thank you.
Yeah. Now it's clear. Yeah, I didn't know this.
Yes, yeah.
Okay, so it has come. So here, when we want to check for the suitability of the pump, we found in this inline drip irrigation system, it is the head required for the system is 67.2 meters, and a 5 HP 8 stage will give us 72 meters. So basically, the head available and the head required, they are matching. There is no problem. But in case you have a 6 stage, what will you do? That means the head is going to fall short. 6 into 9 is 54 meters, which means you'll have to increase the stages of the pump or you have to change the pump. So invariably, the farmer will not be willing to change the pump. You can ask him to increase the stages. And we can also check for the suitability of the horsepower of the pump, which is very important again. So the formula again remains Q into H divided by 75 into 0.6, efficiency of 60%. And we know that the discharge for this system is around 3 liters per second. So 10,800 divided by 3,600 will give us 3 liters per second. And putting it into the formula, we will find that the horsepower required is 4.53. And therefore the pump available, the HP available is suitable. So this is a very easy way of doing the design. I have simplified the design to a very great extent, where typically people look at charts and all that. So this, by this spot design method, you can do the design very quickly. So now one very important part in the design is the discharge or the yield that is available at the field. Most of the time, the design fails because we fail to take the correct discharge. So let me teach you a very simple method of how to find the yield in the borewell. So as you can see that there is a borewell and the water is coming out from there, and there is a barrel. You will generally have a 100-liter barrel or a 200-liter barrel. Please note down the time taken for the water to fill up into the barrel. So the time taken is around 50 seconds. So that means what is the yield? 100-liter barrel has taken around 50 seconds. So it is 2 liters per second. 100 divided by 50 is 2 liters per second. If you don't have a 100-liter barrel, if you have a bucket, then what are you going to do? At least a bucket will be there. So again, you can take 10 liters, say if it is going to fill up in 5 seconds, so 10 divided by 5 is 2 liters per second. But in case of a bucket, the error will be large. So therefore, I would request you to take 3 to 4 measurements. Another important point that you have to keep in mind, always take the measurement of at least after 30 minutes after running of the pump, because what will happen, you will have stock of water due to because the previous day you would have operated the pump, next day there will be a lot of stock of water, and when the stock of water is there, and immediately if you take the discharge will generally be high. Now again, you have to factor one more thing. If you are taken the survey and you have taken this measurement immediately after summer, then this value is more or less correct. But if you have taken it at the end of the rainy season, I would request you to factor it by around 80% or 70%. That means if it is 2 liters, you take for your design 2 multiplied by 0.8, so 1.6 liters per second. So that will be the factoring that you will have to do. So I think this method is very simple to understand. And when we have the products, like I was telling you the chart, so depending on the discharge variation, you could have the extendable length. For example, if the dripper spacing is 40 meters, you may ask me how much long can I run so if it has got a 5% discharge variation, I can go up to 75 meters. And the same thing, as the discharge variation increases, the extendable length of the emitter also will increase. So this is for a 2-liter dripper and this is for a 4-liter dripper. So this is basically the chart which is provided by the manufacturer. At Premier, we provide these charts to all our retailers and sellers, and so basically you can go for the selection. So this is another important thing that you have to keep in mind, and you can decide what is the discharge variation that you want to permit in the field, whether you want to have a 5% or a 7.5% or a 10%. Accordingly, you can select. As you can see, between the 4-liter and the 2-liter, the same configuration. If you take a 10%, if you are using a 2-liter, you can go up to 96 meters, and if you are taking a 4-liter, you can extend only up to 61 meters. Sorry. So basically, the extendable length gets reduced because of the higher discharge. So thank you very much for the interaction session. The time, I hope I finished it in 30 minutes. Yeah, 35 minutes. And thank you very much. And now we will open the session for any questions that may be there. And thank you very much.
Okay, thank you very much, sir, for a detailed presentation. I'll take up the questions from the participants. In the meantime, please stop sharing the screen, sir, so that we can see your full video. Yeah, I'll move on to the questions now. The first one is, most farmers totally depend on the dealers to install their drip irrigation. Is this good or a bad idea?
Actually, like I told you that if the dealer is qualified or if the dealer knows how to do the design, at least the basics, if he knows, then it is good. But generally, it is a good practice to get it done by a qualified engineer. Otherwise, what will happen is you will have problems. Like I told you, that even though the calculations I have explained, they are quite simple, but then when you start installing it, any dealer who has got field experience or anyone who has got basic knowledge and who has to be trained by the company, they will be able to do the design. Otherwise, without any knowledge, if you go and install it, what will happen is you will be giving a wrong size. Whereas if you require a 50 millimeter, maybe he has gone and given a 40 millimeter, and then you will not have the discharge being uniform, and the water will not be reaching to every plant with the required uniformity.
Okay. When a drip irrigation, when is a drip irrigation system badly designed?
The drip irrigation system gets badly designed when you don't visit the plot itself. Somebody will come to your counter or to the shop and tell you, please make a design. So then what happens is, without even visiting the field, if you try to make a design, you generally tend to make mistakes, because I always believe the person who has visited the field, who has done the survey, should definitely go for the design, because then the design will be correct.
Okay, I move on to the next question, sir. Once installed, what is the lifespan of a drip irrigation system?
Yeah, well-designed drip irrigation system, as per the Government of India, should last you minimum 5 to 7 years. We have systems which have been working for more than 10 years, but the basic point you have to remember is, it's not that I give you a drip system. The challenges that the main challenge that is there in the system is that it could get blocked because of the salts. So a frequent maintenance of the system by acid treatment or chlorination will be required.
Okay. What type of maintenance is required for keeping the drip system running smoothly for many years?
Yeah, this I had covered in my third part. Anyway, for the benefit of the viewers, I will tell you there are basically two treatments. One is see what happens is, you have provided a filtration system. It has taken care of the physical impurities. But what about the chemical impurities that are there in the salt? As you know, as we go deeper and deeper, the salt content is increasing tremendously. In such cases, the salt, when the water comes out from the emitter, the water is going to come out from the emitter and the droplet is going to be left over there. When in the heat, what will happen? The water will evaporate, but the salt gets precipitated on the orifice. So that will become the salt precipitation. Generally, looking at the color of the salt, you can decide. If it is generally white in color, it could be precipitation due to calcium and magnesium, which is very common in the water. If it is a brownish color, it could be due to iron. And if it is going to be greenish in color, that means your filtration is bad. You have allowed algae to get into the system. So basically, depending on that, you will have to do that is the first maintenance. You have to take care of the acid treatment. Regular maintenance will be to, like I told you in my other seminar, that every day you have to clean your filter. Simple things, clean the filter. There are no moving parts. Open it up, clean it up, then go to the basic components, check whether the pressures are fine, because the drip system will not work correctly if the pressures are not correct. So please look at the pressures over there. Pressures at different points, at the head control unit, at the submain level, at the lateral level, you have portable pressure gauges. Please go and check if the pressures are correct. It's a good practice too. If it's possible to walk in the field on online easily, you can walk, go and inspect around. It's not that you have got a system. You buy a vehicle, you have to maintain it. Similarly, you've got a drip system, you have to definitely go and take care of the system. So basically, you have acid treatment maintenance and the simple maintenance of cleaning the filters and going up, opening up the flush valve and the end cap for any mud or muck that has accumulated.
Okay. What are the latest technology that is being used in drip irrigation systems?
Yeah, today this is a very good question that has been asked. In fact, today it has become totally digital. For example, you can, but it is again a question of affordability. If the farmer or the corporate is able to afford these systems, you can go in for automated systems where you have either a timer based or a volume based or a real-time based system. That is one available. And now even later systems, like people are using remote sensing and indices like NDVI and all that, wherein you can exactly know the moisture status, and based on the moisture status of the soil, you can do a real-time irrigation. So a lot of digital interventions and disruptive technologies are there in the picture today, and these technologies can be used. But again, you will have to look at the cost benefit part of it. A small farmer, it's not required. Automation is really required only when the area is large and when you have to control a large number of wells. Otherwise, a simple drip irrigation system, you just need to have the regular farm labor. One farm labor can easily take care of 5 to 10 acres without any difficulty.
Okay. How do you think drip irrigation technology will evolve in future years?
Drip irrigation technology has become commoditized today. So that is the real truth, that it has got like commodity selling. People come into the shop, they just buy the lateral and go, but they don't know how to install it correctly. So basically it has become like a cottage industry. But then there are companies who are taking a lot of care in doing a tailor-made system. I believe that every drip system has to be tailor-made. It has to be tailor-made and designed and given. So you will have one set of customers who will want picking up the material from across the counter, and another set of customers who are actually going to go into the project mode where you're going to have the different designing and other aspects coming to picture. So this is the way the future looks very good, only because what is happening, a lot of money is being.
Sir, can you please unmute your mic, sir?
Yeah, there are a lot of the government of India has given a lot of amount from the Pradhan Mantri Krishi Sinchai Yojana, and different state governments are adopting different patterns. So we should have a good transparent system, and whereby the subsidy reaches the farmer. And okay,
Yeah, you finished it, sir?
yeah.
Okay. The next one is, please tell us about yourself. What is your career background? What do you like most about this job?
My name is Vijay Kumar. I am working in the field of micro irrigation for the last 32 years. The most thing that I like is to teach and to share my knowledge that I have gained over the years. I believe I learned all my designing and all my thing, the real part, from the farmers and from the field experiences. So that is my first liking. And basically on my qualification part, I'm a civil engineer with a post graduation in hydraulics and water management from NIT Surat. And I am very happy to be sharing this knowledge for the entire micro irrigation community. And I'm from Premier Irrigation. I am working with Premier Irrigation for the last 20 years.
Okay, okay. That's very nice to hear, sir. We have many participants from your side also who have logged in here. Few have posted their queries also. I will just read it out for you, sir.
Okay.
One, Mr. Anand is asking reason behind running the drip line in east-west directions.
See, you know that the rows, like I showed you in the diagram, the sugarcane planting or the vegetable planting is in which direction? So that is important. It is in the east-west direction. The rows are in the east-west direction. If I try to put the lateral in the north-south, I will not be able to put it at all. I have to put it in the direction along the rows. So basically, the rows in that design, if you remember, was from east to west. North-south is the direction for the submain or the main.
Okay, the next question is from Ms. Shruti. She's asking, in case we are self-installing for a small personal plot using the instructions you provided today, is it possible to do it on our own?
Yeah, it is definitely possible. We have, in fact, from our company, we have launched small kits called as EZ kits, and from the kits for 100 square meter or 200 square meter for either a kitchen garden or for a terrace garden, definitely we can do the drip irrigation. You just need to have a tank, and from the tank we can connect these pipelines, and we can give the required quantity of water to each and every pot for the garden, kitchen garden.
Okay, I see some hands raised, sir. Miss Anupama, you can just unmute your mic and ask your question. Mr. Anupam? Mr. Jana? Please unmute your mic.
Yeah, good afternoon, sir.
Good
Sir,
afternoon.
can you tell me, sir, actually what will be the head loss for gravel filter and hydrocyclone filter?
The head loss for the gravel filter varies between 5 to 6 meters, and for the hydrocyclone filter is also around 4 to 5 meters.
Thank you.
Okay, and Mr. Anupam, now you can unmute your mic and ask your question. Mr. Anupam? Or if you're not able to unmute your mic, you can post your question in the chat box.
Yes, ma'am.
Yeah.
Anupam from Jabalpur.
Yeah. Please ask.
सर मैं ये पूछना चाहता था कि ये जो लेटरल चोक होती है, जो ड्रिपिन की जो लेटरल चोक होती है, उसमें ब्राउन कलर के जो पार्टिकल्स कई जगह पे मेरे को देखने को मिलते हैं, कई जगह पे तो व्हाइट कलर के देखने को मिलते हैं मैक्सिमम जगह, मगर कई जगह ब्राउन कलर के पार्टिकल्स या हरे कलर की काई देखने को मेरे को मिलती है, तो उसको कैसे साफ करना चाहिए सर?
तो
उसके लिए कौन सी है?
बराबर जो आपने बताया अभी, ब्राउन कलर का जो है वो एक्चुअली ड्यू टू आयरन के लिए आयरन के लिए, सो आयरन को निकालने के लिए बहुत मुश्किल है। सबसे तकलीफ ट्रीटमेंट देना पड़ेगा आपको वहां आपको एसिड ट्रीटमेंट फॉलोड बाय क्लोरिनेशन दोनों भी करना पड़ेगा, ताकि और एक और दूसरा मेथड है जो ऑक्सीडेशन। ऑक्सीडेशन वो बड़ी प्रमाण में नहीं कर सकते, इसलिए हम लोग क्या कर बोलते हैं दैट बेसिकली अगर आपका कुआं है उसी में से आपको ऑक्सीडाइज करके आयरन को निकालना चाहिए, अदरवाइज फ्रीक्वेंटली आपको एसिड ट्रीटमेंट करना ही चाहिए। हाइड्रोक्लोरिक एसिड या फॉस्फोरिक एसिड यूज कर सकते हैं।
सर वीकली करना चाहिए या मंथ में एक बार करना चाहिए या 2 बार?
ये आपको क्या है, आपको डिसाइड करना पड़ेगा कि आपका कितना जल्दी चोक हो रहा है। हमारा ये रिकमेंडेशन है कि हमको हमारे सिस्टम में 3 महीने में एक बार करना चाहिए। अगर ब्लॉकेज हो ना हो, आपको 3 महीने में एक बार करना ही चाहिए। मगर समझो आपका जल्दी जल्दी, जैसे मैं कड़पा में गया था, वहाँ कड़पा में सेम प्रॉब्लम आया था, रेड कलर का या ब्राउनिश कलर का चोकिंग था। वहाँ हमने डिस्कस किया और वहाँ हम मंथली वहाँ कर रहे हैं, क्योंकि वहाँ का क्यों जो हम बोलते हैं पीएच वो करीबन 9 ऑलमोस्ट 8.5 तक था, एंड वहाँ पूरा जल्दी जल्दी वो रस्ट में कंटामिनेट हो रहा था। तो ये एक्चुअली वाटर का क्वालिटी का इश्यू है। सो इसमें क्या बोलते हैं ना, एवरी सिस्टम हैज गॉट इट सम लिमिटेशन, तो इसलिए हमको हर मंथ में हमको क्लीनिंग करना पड़ेगा।
सर एक चीज और पूछना चाहूंगा सर।
हाँ जी
सर नेटाफेम के जो कस्टमर हैं
हम्म
वो फ्लैट लेटरल लेना ज्यादा पसंद करते हैं राउंड लेटरल की अपेक्षा। वो कहते हैं कि फ्लैट लेटरल को लंबी दूरी तक ले जाते हैं, उसमें हेड लॉस वगैरह, फ्रिक्शन लॉस, ये सब चीजें कम होती हैं। आपकी जो राउंड की लेटरल है ठीक है, उसमें 4 छेद होते हैं, पानी चोकिंग नहीं होता और वो है, मगर फिर भी वो फ्लैट लेटरल ज्यादा यूज करते हैं। तो उनको कैसे मतलब अपन तो बताते हैं उनको कि भाई हमारी लेटरल में 4 हिल टेक्नोलॉजी है और उसमें चोकिंग की प्रॉब्लम कम है, मगर फिर भी वो मतलब डाइवर्ट तो हो रहे हैं अब धीरे धीरे, मगर प्रॉब्लम होती है थोड़ा सा। क्या करना चाहिए सर?
सी एक्चुअली क्या है, मार्केट में दो तरह, जैसे आपने बताया, एक आपको आता है जो ड्रिपर सिलेंडर फ्लैट होता है, दूसरा जो
हाँ
होता है सिलिंड्रिकल होता है। तो ये
जी
दोनों
सर।
टाइप का ड्रिपर आपको मार्केट में अवेलेबल है।
जी
तो कौन कौन अच्छा है? सो जैसे अभी बेल बॉटम स्टाइल भी पहनते हो और नैरो बॉटम भी स्टाइल पहनते हो, कौन सा
जी
अच्छा है?
सर।
तो आप अपना अपना पसंद। तो हमारे
जी
कंपनी में दोनों प्रोडक्ट अवेलेबल है। और हम
जी
लोग क्या है, हम सिलिंड्रिकल एमिटर इसलिए पसंद करते हैं क्योंकि क्या है, फ्रॉम अ प्योरली हाइड्रोलिक टेक्नोलॉजी पॉइंट ऑफ व्यू, सिलिंड्रिकल ड्रिपर में क्या होता है, उसका
जी
जो
सर।
फ्लो पाथ लेंथ जो होता है वो बहुत बड़ा होता है। तो
जी सर।
यूनिफॉर्मिटी ऑफ वाटर, जो रेगुलेशन
जी
ऑफ
सर।
वाटर जो हम बोलते हैं, वो बराबर आता है। मगर फ्लैट एमिटर जो आता है उसमें भी आजकल टेक्नोलॉजी अच्छा है, उसमें भी यूनिफॉर्मिटी अच्छा आता है। और ये सिलिंड्रिकल और फ्लैट में क्यों आया, ये कॉस्ट कम करने के लिए। पहले पूरा आता था, सबसे इवन नेटाफिम भी अपना पहला ड्रिपर जो इन्वेंट किया था वो सिलिंड्रिकली इन्वेंट किया था। बाद में
यस सर।
कॉस्ट कम करने के लिए, और वहां से जब शिप में मटेरियल आता था तो
जी
आपको
सर।
फ्रेट, उसमें क्या होता है, फ्रेट का बहुत बड़ा कॉस्ट होता है। तो कॉस्ट कम
जी
करने के लिए उन्होंने फ्लैट एमिटर का दिया है। हम लोग भी फ्लैट भी बनाते हैं और सिलिंड्रिकल भी बनाते हैं।
हाँ जी सर।
जो भी सिस्टम हो, मगर आपको मेंटेन करना बहुत इंपॉर्टेंट होता है, जो भी सिस्टम हो।
जी सर।
मगर एक एडवांटेज मैं फ्लैट के लिए बोलना चाहता हूँ कि आपको फोल्ड करके रखने में थोड़ा इसकी इसकी आसान आसान हो सकती है। इसमें सिलिंड्रिकल में थोड़ा वो बेंड आ सकता है। तो
पेंड
मगर
आ
इसके
सकता है
लिए भी
जी सर।
सोल्यूशन है, आप लैटरल को पुल पकड़ के उसमें एंड में आप पेग डाल के उसको बांध दीजिए, वो प्रॉब्लम नहीं रहेगा। मगर प्योरली हाइड्रोलिक पॉइंट ऑफ व्यू, ये सिलिंड्रिकल जो एमिटर है, यूनिफॉर्मिटी एंड लेबरिंथ का लिंक वो सब पकड़ के ये अच्छा है। तो फ्लैट में भी आजकल टेक्नोलॉजी अच्छा है। तो रियली
जी
आई विल टेल बोथ आर इक्वली गुड।
थैंक यू सर।
Okay.
थैंक यू सर।
Thank you.
Okay, thank you, sir. Let me check if we have any further questions. I don't see any. Okay, I don't see any further questions, sir.
Okay.
Thank you very much. We have now completed the round of questions. On behalf of agricultureinformation.com, I thank Mr. S. Vijay Kumar for the talk and for answering the questions in detail. I also like to thank all the participants in this meeting. This meeting will now be closed.
Thank you very much, madam.
Yeah, you're welcome, sir.
Thanks, sir.
Thank you.
थैंक यू सर।
Thank you, sir.